I'm a bit disappointed because I thought I was going to be the only one with props. So like I was like, yeah, I'm gonna get it, but you see that this year it's about this. So okay, I'll try. So I am a scientist and I work with nanotechnology. Nanotechnology is basically the science of things that are very, very small. So a nanometer is about 1,000,000 times thinner than your hair, that's the thickness of your hair. So I'm working with materials that are very, very tiny. And it looks like very like from the future and stuff, and you're like, ooh, fancy, like expensive materials. Actually, flowers in your garden, animals that you see every day, they all contain nanotechnology. So one of the animals that I really like are geckos. So they're these lizards that can like climb in walls and stuff. And the way they do that is not because they have like a super powerful glue on their feet or anything, it's because they have nano hairs on their feet. So I have here a very sophisticated prototype of what a gecko feet hair looks like. They're called setae because they look like mushrooms. And they have this flexible stem, and then they have this flat cap on the tip. So what they do with these hairs that they have on their hair is that they can use that to actually conform to the surface. So that means that when a surface like a wall that you think is flat, well, if you're actually looking at it close, like really close, it's not flat. It has like a lot of holes and pits and like bumps and stuff. So all these hairs, what they do is they conform to the surface. So you are increasing the surface, the contact area. And that is what you do when you're trying to walk on ice and you're walking with your flat feet on the ice. That's actually because what you're doing is increasing the surface area of your feet with the ice to increase the friction. So the more friction, the more you stick. The impressive thing is that these geckos can actually climb upside down and like on the walls and everything. So it's not something that we as humans know how to do, but we would really like to do that. And we could climb things like Spider-Man stuff, so that's cool. So actually, the thing that makes me special in here today is that I'm actually going to do a live experiment on gecko walk. And what I have here is another very sophisticated prototype of gecko feet. So this would be a human feet, which is like flat, right? And then that's how your feet look like, kinda. This is a gecko feet, and I make here a cartoon for everybody to know that it's a gecko. Thank you. And this would be the nano hairs that they have. So imagine that each one of these hairs is around 100 nanometers thick. So they're very, very tiny, and they're like very dense on the surface of the feet. And then I wrote these as surfaces that are like microscopic representations of surfaces. So the way humans walk is you just put your feet and then that's it. But the way geckos walk actually, because they have this special system, is they walk and they put like a little wiggle on it and then they put pressure on it. So it's not just walking, it's actually walking and like wiggling. And now this is the moment of truth. I've only tried this 3 times before coming here, so I really hope it works. But now, hopefully, we will see the difference. Oh no. Yes. Oh no. I hope you all saw that the gecko stayed longer on the tennis racket. So that means that the gecko is increasing the friction because the hairs get tangled in the little roughness of the surface of the wall, while the flat feet just doesn't really have any friction with the roughness of the wall. And that is how geckos walk on the wall. Thank you.